Okay, so today we're graphing the cube root function. So this is the cube root function, f of x equals cube root of x. So we're going to start by graphing this using a table. So what we'll do is we'll plug in -8 to x. If you're wondering why I picked these values, I can take the cube root of these values very easily, so that's why I picked them. Okay, so cube root of -8, you have to think what times what is -8? And that would be -2. -2 times -2 is +4, times -2 is -8. So -2 is the cube root of -8. Next, cube root of -1, what times what is -1? That's -1. Cube root of 0 is 0. Cube root of 1 times 1 times 1 is 1. And cube root of 8 is 2, because 2 times 2 times 2 is 8. Now we will graph these values. So we have -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. And then you will connect them, and it makes like this S shape. Kind of weird. That's what the cube root function looks like. It's like this weird, almost like a flattened S. There kind of is a pattern for this. I don't really think of it as a pattern, but I guess you could say like, okay, starting here, go up 1 over 1, up 1 over 7, and then you'll go down 1, left 1, down 1, left 7. You can think of it that way if you'd like. X and Y-intercepts, X-intercept is 0, 0, and the Y-intercept is also 0, 0, so 0, 0, and 0, 0. Domain, all of your possible x values, and range is all your possible y values. So all your possible x values, they go from -infinity all the way to +infinity. Any x values you want are on this graph. So -infinity to +infinity. You could write it like that, or you could write it as all real numbers, or all reals, that's fine too. Your range, that's all of your possible y values. So your y values, they're just going to keep going up and up and up and up very, very slowly, but they do keep going up and up, and they keep going down and down, down, down. So it's -infinity to +infinity again. Or once again, you could say all reals, all real numbers, whatever you want, okay? All right, next. What are the maximum and minimum values for f of x equals the cube root of x over the interval -8 to 8? So here we're just looking specifically at -8 to 8. So the minimum value is -2. Your minimum value is whatever your smallest y value is. And then your maximum value is your highest y value, which is 2. Now remember, this does go on forever, but if you're chopping the graph off here between -8 and 8, that's what it's asking. So your max is 2, and your min is -2. Okay, next. Graph f of x equals -cube root of x. So you could probably think what's going to happen to this graph. It is going to be reflected over the x-axis, so we can write that in for our transformation. Okay. All right, so the cube root of -8 is -2, but there's a negative in front, so -2 is +2. The cube root of -1 is -1, but there's a negative in front, so -1 is +1. Cube root of 0 is 0, -0, no such thing, just 0. Cube root of 1 is a 1 with a negative in front, so that's -1. Cube root of 8 is 2 with a negative in front, so that is -2. Okay. Now we're going to graph these values. So -8, -2, -1, 1. Oh, I'm sorry. I don't know what I'm doing. First value is -8, +2. Sorry about that. -8, +2, -1, 1, 0, 0, 1, negative 1, 8, negative 2. Okay, so connect them, it makes this S shape, and it's just kind of like, it just flipped over the x-axis, because if you compare it back to that first graph, like see this part is like flipped over this way, and this part is flipped down that way, and that's why it's like opposite. Okay, X and Y intercepts, same thing, 0, 0, and 0, 0. Your domain, all of your possible x values go from negative infinity all the way to positive infinity. Or you could say all reals. Same thing with the range. They're going to go up and up and up, and they're going to go down, down, down. Negative infinity to positive infinity. And it's reflected over the x-axis. That's your transformation. Okay, next. Graph f of x equals the cubed root of x plus 2. So for this one, let me focus this. That's better. Okay, so for this one, we're going to plug in negative 8. The cubed root of negative 8 is negative 2. Negative 2 plus 2 is 0. Cubed root of negative 1 is negative 1 plus 2 is 1. Cubed root of 0 is 0 plus 2 is 2. Cubed root of 1 is 1 plus 2 is 3. Cubed root of 8 is 2 plus 2 is 4. Let's graph these values. So we have negative 8, 0, negative 1, 1, 0, 2, 1, 3, 8, 4. Connect them. So as you can see, our graph is shifted up 2 units, okay? So it's normally here is where you're, not really the vertex, but you know what I mean? Like that center point is usually here, and this is now shifted up 2. So that's your transformation, is shifted up 2 units. X and Y intercepts. Your X-intercept is negative 8, 0. So X-intercept is negative 8, 0. Your Y-intercept is 0, 2. Your domain, all of your possible x values, same thing, negative infinity to positive infinity. And your range also goes from negative infinity to positive infinity. Next, graph f of x equals the cubed root of x plus 1. Okay, so for this one, since this is under the radical, this is going to be shifted to the left one, the opposite of what's under the radical. So negative 9, the cubed root of negative 9 plus 1. So negative 9 plus 1 is negative 8, and the cubed root of negative 8 is negative 2. For this one, the cubed root of negative 2 plus 1 is negative 1, and the cubed root of negative 1 is negative 1. Cubed root of negative 1 plus 1. Well, negative 1 plus 1 is 0, and the cubed root of that is 0. Plugging in 0, 0 plus 1 is 1. Cubed root of that is 1. Plugging in 7, 7 plus 1 is 8. The cubed root of 8 is 2. So that is where we're at right now. Now let's graph these points. So we have negative 9, negative 2. We have negative 2, negative 1. We have negative 1, 0. We have 0, 1. And we have 7, 2. Okay. Makes sense because I usually could see this kind of center point here is shifted left 1, right? So shifted left 1 unit is the transformation. Now remember, you could always just go to, so you could look at this, instead of making a table, you can go left 1 unit since you know it's going to be shifted left 1, and then you could be like, okay, I'm going to go up 1 over 1, I'm going to go up 1 over 7, and I'm going to do the same thing in the opposite direction. And then you could graph it with that pattern if you would like, since A is 1. Now if I put like a 2 in front of here or something, you can't do that. Okay, X-intercepts. X-intercept is negative 1, 0. It's where it's crossing that x-axis. Y-intercept is this point, so that's 0, 1. Okay. Domain, negative infinity to positive infinity, it's all those real numbers. All reals. I'm just writing it different ways, but it doesn't matter the way you write it. And then the range, same thing. Your y values are going to go up and up and up, and your y values will just keep going down. So all reals. Okay, we're on our last page now. All right, so graph f of x equals cubed root of x minus 1 plus 2. So this is going to be shifted right 1 unit and up 2 units. Shifted right 1 unit and then up 2 units. Okay, plugging in -7. -7 minus 1 is -8. Cubed root of -8 is -2. -2 plus 2 is 0. 0 minus 1 is -1. Cubed root of -1 is -1. Plus 2 is 1. 1 minus 1 is 0. Cubed root of 0 is 0. Plus 2 is 2. 2 minus 1 is 1. Cubed root of 1 is 1. Plus 2 is 3. 9 minus 1 is 8. Cubed root of 8 is 2. Plus 2 is 4. Plotting these values, -7, 0, 0, 1, 1, 2, 2, 3, 9, 4. As you can see, it's shifted up 2 units, because here's that center point, right? And then it's shifted right 1 unit. Okay. X-intercept is -7, 0. Y-intercept is 0, 1. Domain and range, same thing. Negative infinity to positive infinity. Negative infinity to positive infinity. Now, the other thing I want to mention is sometimes when you graph these, you're not really going to be able to clearly see your x or your y-intercept. So if you can't clearly see it, if you're finding the y-intercept, let's say, you're going to want to set x equal to 0. If you're finding your x-intercept, set y equal to 0 and solve. You should be able to figure out how to do that. So if you can't clearly see it on your graph, do that and just solve it through. Okay, write an expression for each function. So this one, a translation 5 units up, so that would be f of x equals the cubed root of x plus 5. For this one, 2 units down would be f of x equals the cubed root of x minus 2. And for this one, f of x equals this 3 units right. So 3 units right, remember it's the opposite of that, so it would be minus 3 under the radical. And then 8 units down, minus 8. Okay, average rate of change. We're only going to do one of these because I think you should kind of know how to do this by now. Average rate of change is finding the slope, so we just have to plug in our values on our interval and then find the slope. Okay, so we're going to start with f of 4. So f of 4 is the cubed root of 4 plus 3. Okay, cubed root of 4, you really can't do that in your head. You're going to need to use the calculator. So I have 2 different calculators because I know you guys have all different calculators. Okay, so if you're doing it in this calculator, the TI-34, you would put a 3, and then you're going to go second, caret, and then 4, like that. and then you add 3. Okay, so that's how you would do it in this calculator. In a graphing calculator, you would do, you go to your math function, scroll down to cubed root, enter, cubed root of 4 equals plus 3. Okay, so I'm going to round this off, so f of 4 equals 4.59. So 4.59 is one of your points. Now we have to do f of 7. So that would be the cubed root of 7 plus 3. When you do that in your calculator, you will get 4.91, rounding off. And then it's 4.91 is your point. So then remember, it's y2 minus y1 over x2 minus x1 to find your slope. So 4.59 minus, whoops, this is 9.1. I don't know why I put 4.1. I'm going to subtract the other way actually to keep it positive. I'm going to go this minus this, this minus this. So 4.91 minus 4.59, and then 7 minus 3. So 4.91 minus 4.59 is 0.32, and then 7 minus 3 is, why am I putting 7 minus 3? I'm like losing it, sorry guys. 7 minus 4 is 3. There we go. Okay. 0.32 divided by 3 is 0.107. About that. Okay, that's about your average rate of change. Okay, that is it. Sorry, this is a longer video. Have a good day.